An important part of IFC's mission to help. Welcome to the IFC SES tool, dedicated to sustainable energy financing for enterprises and businesses. I am Trey, your guide for this e-tool. Before I introduce the different sections to familiarize you with it, thank you for your interest. Let us start with an overview of the e-tool. This e-tool was conceived to create awareness among enterprises. This e-tool contains core sections. I will take you step by step through each of these sections. After going through the different sections of the IFC SES e-tool, we hope you will have a good grasp of. This section introduces ways to benchmark the performance of your facility's energy use by gathering and analyzing relevant data pertaining to energy use and the industrial production. A typical industrial facility may comprise of various energy systems and services, such as the process equipment, cooling and heating utilities, compressed air, and lighting. However, depending on the industrial activity, some may require more or less types of systems and services than others. The industrial facility would need various forms of energy, such as electricity, coal, and oil, etc., for the production process. If energy is used rationally and efficiently in the industry, it can lead to several benefits: better working environment, lower operating costs, more competitive in the market, and minimum environment impact. You may plot the data of monthly production rate and energy costs for the different months of the year. Instead of just plotting the data for the different months, it is possible to plot one parameter against another in order to see if there is any correlation between the two. For example, in this case, the specific energy cost, i.e. energy cost per unit output, plotted against the monthly production, shows a strong correlation between the two. As one would have expected, the specific energy cost reduces during the months of higher production rate. If you keep track of the energy performance of your industry, you will be in a position to compare your data with the energy consumption benchmark for similar industries in your country or anywhere else, and judge for yourself how well is your industry performing. The figure shown is based on IFC's survey of the energy performances of different industrial subsectors in Vietnam. Absence of energy management can have adverse impacts on the profitability of an organization. When energy costs rise, the management gets concerned and looks for ways to reduce the energy bill. This section introduces the sustainable approach to energy use in your facility. While establishing a new industrial plant, we include the major process equipment, control systems, and auxiliary utilities. Energy demands of the different processes and utilities add up to make the energy demand column grow bigger and bigger. Under normal conditions, all the energy requirements of the facility are met by fossil fuel sources. Let us see how energy demands of process equipment, devices, and utilities add up in the example of an industrial facility. How can we become more energy efficient and less reliant on fossil fuels while meeting the building's energy services? There is a sustainable approach which involves a step-by-step process to we can lower the energy demand of the industry at the designing phase by starting with the assessment of the exact requirements and adapting the processes to the required output. Optimized design features will help to lower the demand for energy services, as well as the installed capacities of the equipment and appliances. Depending on the price of energy purchased, we can justify investment in energy-efficient solutions up to a point where the energy cost savings outweigh the capital investment. With a substantial reduction of the demand for fossil fuels, we will no longer have to worry about fuel price hikes and energy security issues. Further, energy efficiency measures require lower investment than renewable energy at the initial stage of the campaign. We can achieve high savings while investment stays low, reflected by negative incremental life cycle costs. EV measures implementation lock in energy consumption reduction. Investment in each additional unit of savings would cost more, reflected by positive causes incremental life cycle costs. At a certain point, energy efficiency measures become more expensive than renewable energy technology in order to save or avoid a unit of energy. A steel billet manufacturing unit plans to adopt energy-saving measures to reduce the production costs and enhance energy productivity. With application of new and higher energy-efficient technology, huge energy savings can be achieved. By adopting heat recovery measures, further energy-saving targets can be reached. And finally, let's see the benefits of adopting a step-by-step approach. In this section, I will show you how the purchased energy is converted to provide energy services needed by the facility and the approach to maximize energy savings. Lighting accounts for about 20 to 45% of energy use in a commercial building and about 3 to 10% of energy use in an industrial plant. Cooling systems can be divided into two categories: process cooling in production plants and comfort cooling in commercial buildings. Pumps are widely used in industrial and commercial applications. They provide cooling fluid transfer in processes. Pumps represent 27% of electricity used by industrial systems. Process heating is essential in the manufacture of most consumer and industrial products, including those made out of metal, plastic, rubber, concrete, glass, and ceramics. Steam today is an integral and essential part of the industry. Industrial plants use compressed air throughout their production operations. Compressed air is produced by air compressor units ranging from 5 horsepower